All right, so our first problem was that indices are ints, but keys can be anything. So our solution, I said, was basically, wait, isn't everything just a number on a computer anyway? Right? Everything is just numbers. Everything is just stored in binary in zeros and ones, even the words, right? So worst case scenario, everything is a word. Sorry, is a sequence of numbers. Right? It doesn't matter if it's a scanner, doesn't matter if it's a string, doesn't matter if it's some weird kind of object, doesn't matter if it's another hash table. That can be represented in numbers, specifically zeros and ones. So in theory and in practice, we can turn anything we need to into a number. So the true solution is to 1, where basically the keys can be anything, but indices are integers are, well, have a way to turn keys into integers. All right, so how do we do that? Well, worst case scenario, again, we can just take the binary representation of what it is and convert it into an index, right? Ignoring basically the size constraints of our index. But the real way we can do that is we let Java handle that for us, that whole turning any key into a number, right? Because worst case scenario, again, everything in this computer is a number. But everything in Java has the hashcode function, has .hashcode, which is this function, which we'll refer to as h of x, where x is the key, that takes in anything at where x is some key, and gives us a, some kind of hashed value, as we call it. Some value that translates this anything into a number that we can use. So that's solution number 1. Well, if it's not it, our issue was that we had keys that were anything, but if we want to use it as the index in an array, it needs to be an integer. So turn it into an integer. See, problem 1 is pretty simple and straightforward, and we're going to wave our hands and say that a wizard does it for right now with the hashcode function. Problem number 2 is pretty much as straightforward. Now, if you remember, problem number 2 is that this is a giant array, right? All right, and the solution to that one is also fairly straightforward. So your problems here using a giant array. The solution to that is you don't use a giant array. So what we'll do is we'll do with what we do with an array list approach, right? We could map out 1 million items for an array list and then proceed to only use 10 of them, but that would be stupid because that would waste a whole lot of memory. So instead what we're going to do is we're going to start out with a reasonable amount of size for an array list. We'll start out with maybe 11 slots or 13 slots to put into a hash table. And instead, as the hash table grows, we'll just simply grow it in size rather than using everything instead. So how do we, but wait, so we're going to be taking a giant integer, right? Some giant number from 1, right? We're going to be taking this key, right, and transforming it. Okay, so solution to 2, right? We'll just write down first, solution to 2, solution, don't use big array, start small, build bigger, like array list. With a big caveat there is that we're going to have to come back to that. Okay, so how's that process going to actually work in theory? Because again, well, if we're starting with a smaller array, right, say this array is of size 11, right, and I've got this key, right, so you're telling me I'm going to take this key, some value, and it's going to give me a hash value, right, and this will turn it into some number, and I'm going to use that number as the index I should put this in, and say this number gives me back, this function gives me back the number 1 million, right? Well, this is a size 11 array. How can I possibly fit this as a valid index? And the answer is, well, what we'll do is that we'll just mod it to the current size of the array. So by 11 this time. So mod by table size, we'll call it. So the size of the hash table. And that way, basically, any possible value has a value in here, which will lead us to a third problem, but I'll address that when we get to that. So how does this contraption work? And I'll put my array over here on the right so I can use more of my whiteboard over here. 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 6, 7, 8, 9, 10. Right, suppose we take some, so suppose we wanted to insert the, we wanted to put, let's see, A as our key, and I wanted to put, actually I'll go with A, B, C, D as our key, and I wanted to put foo as our value. So our key is a string and our value is a string, and I want to put this in there. So the first thing I'll do is I will throw, to put this in, what we'll do is that it will put A, B, C, D into the hash function and get some number out of it, right? It'll get some number out of this. Now that number is probably going to be much bigger than the size of an index than this 10, that's the maximum index available for my hash table. So what I'm going to do instead is that to make it fit, I'm just going to mod it by the table size. So suppose I get it out, I get this, and it says that it is we'll get some number out of this. We mod it by 11, and let's say that the value it gets is 4. So this will go ahead and map. So we'll go ahead and put foo in index 4. Now the key to the hash function is that takes constant time. The modulo function takes constant time. It doesn't in comparison to the size of the array. So as this array gets bigger, as the hash table gets bigger, this doesn't take any longer than any other operation. Okay. So then I could put h. So say I wanted to then get the value for associated with A, B, C, D. What we would do is that we would calculate, throw ABCD into the hash function, so we'd call abcd.hashcode, mod it by the table size. That would give us index 4 back, and then we return it. Why index 4? That's just the one I happen to choose, right? It really just depends on the internal state of the hash table. And so then, say we insert other items, like we'll insert something with another imaginary key, and we'll put like a bar over here, and we'll put Boz over here, and then Fred over here, and then Ed over here, and as it fills up, that will, the array will get full, more and more full with the values. And we can kind of see why I mentioned earlier that the idea is that there's no order to a hash table. That when we iterate through it, there's no kind of relevance as to what got added first versus our values sorted. There's just no order. So this value will just fill up based on what the keys are and how the modulo operation works, which is a bit hard to predict. So this does, I did mention though a third problem. So see if you can think of it before the next video.